Hello everyone, myself Muniraju Naidu, Assistant Professor, Department of Computer Science and Engineering, working at Institute of Aeronautical Engineering, Hyderabad. So today I am going to discuss about operating system structures. So in the previous video already we discussed about what is operating system, what is the purpose of operating system, and how the various components are interconnected to each other, that is a computer system structure. Now coming to this operating system structures, so these are the concepts in these operating system structures: operating system services, user operating system interface, and operating system structure. So we know basically operating system acts as an interface between user as well as the system hardware. So by default the operating system provides some services to the user. So what are those services provided by the operating system, and with the help of those services, how the various functions of operating systems are executed. See, these are the objectives of operating system: to describe the services an operating system provides to users, processes and other systems, and to discuss the various ways of structuring an operating system, and to explain how operating systems are installed and customized and how they boot. So these are the basic objectives regarding to the operating system structure. See, these are the various operating system services. We know that operating systems which provides an environment for execution of user programs, as well as the operating system provides some services to the programs as well as the users. See, one set of operating system services which provides functions that are helpful to the user. So we can say that these services are related to the user's point of view as well as related to the system point of view. So one set of operating system services which provide some basic functions which are very helpful to the user. Those are user interface, program execution, I/O operations, and file system manipulations, communications, and error detection. User interface. So you know the definition itself specifies that operating system acts as an interface between user as well as the system hardware. So user interface which provides some basic functions, that is almost all the operating systems have a user interface, right? So those user interfaces may vary, depends upon the operating system. So basically these user interfaces may be classified into command line interface as well as the graphics user interface. So we know the well-known examples for command line interface like MS-DOS and MS-DOS and UNIX operating system. Whereas graphics user interface, the best example for graphics user interface, that is Windows operating system. So these user interfaces may vary between command line interface, graphics user interface, and some batch systems. Now the second operating system service, that is the program execution. So the program execution means that whatever the system, that particular system must be able to load a program into the memory. You know, into the memory in the sense primary memory, and to run that particular program from the primary memory. If it is success completely, then automatically it stops that particular execution. Then we can call as a end execution, either normally or abnormally. So when we can say that normal execution, if according to the requirement, whatever the input given by the user, the exact output, then we can call as a, that is the normal execution. Right? Abnormally means if anything happens, if any error is there, then whatever the requirement, that particular requirement doesn't met according to the user's point of view, then we can call it as that is a abnormal execution. So this is another service provided by the operating system, that is program execution. Then third one, input output operations. So we know that any particular program, that particular program must need some input output. Or if you take any particular application, that particular execution of that particular application must involve to communicate with either file or an IO device. So this is another service provided by the operating system, that is input output operations. It specifies that any running program which requires either input or output, or which may involve a file or an input output device. Then next service provided by the operating system, that is a file system manipulation. So we know in any kind of operating system, the file system is very important, because whatever the application programs, that particular programs need to read and write files as well as the directories, and we need to perform some operations on those files as well as the directories, like create and delete, search, as well as the list file information, permission management. So it depends upon our requirement. Right, we have gone through that various operations. That is simply represented as this is another kind of operating system service. We can call it as a file system manipulation. Then communications. See, whenever we can say that one particular process which is executing on one particular system. So we know that particular system simultaneously executed more number of processes. Definitely, each and every process must communicate with some other process which may be executed on another system or another network. So let us take one is source, another one is destination. Right? So the source node which comes under the Airtel network, the destination node which comes under the Jio network. Now what happens, whatever the individual processes running on these two different systems, definitely each and every process must exchange some kind of information, whether that particular information may be file or directory, whatever the thing according to the requirement. Right? So we can say that processes may exchange information on the same computer or between different computers over a network. So this particular communication must be done with the help of either shared memory or through some message passing techniques. And next service provided by the operating system, that is error detection. So we know in the previous video also we discussed that each and every time the operating system alerts the user whether that particular program is or application is executed successfully, it shows some message. If any interrupt is there, it shows some message. So that means operating system needs to be constantly aware of possible errors. Right? So what kind of errors? So that may varies. Right? So these kind of errors may occur in the processor as well as the memory hardware, and in case of input output devices in the user program. But if whatever the scenario, whatever the error on which device that particular error will execute, right? For each and every type of error, the operating system should take the appropriate action to ensure that correct and consistent computing. So the operating system itself is having some debugging facilities which greatly enhance the users and programmers' abilities to efficiently use the system. So that's why we know the basic goal of operating system is efficient to use as well as the convenient. It provides some convenience to the user. So with the help of this particular error detection facility, we can call it as a service provided by the operating system, that is error detection. So with the help of this, the operating system should take care about appropriate actions to ensure correct as well as the consistent computing. So these are the various services or functions provided by the operating system. See, this is we can call as a operating system services within a single pictorial representation. See here, the bottom level layer, that is the hardware, then operating system, here users and other system programs. So first of all, the definition must be matched. That is, operating system acts as interface between user as well as the system hardware. So that will satisfy this particular pictorial representation, right? Then coming to the whatever the services provided by the operating system, those services here we need to mention that program execution, input output operations, file systems, communication, resource allocation, accounting, error detection, protection and security. Right? See, protection and security, accounting. So, this particular accounting is also very important. That means nowadays we are using multitasking, right? So, number of processors, number of users may be communicated to each other. So, which user may use which particular system? On what time that particular user allocates some resources to some other systems. So these are all the information maintained in this particular functional, that is we can call as a accounting. Then resource allocation. So this particular resource allocation is very important because this is the most important operating system service which provides to the users. So we have different resources like physical resources as well as the logical resources, right? So who provides that particular resource to my particular process? Is it right? For example, I need to create, let us take a simple example. I need to create one particular biodata, and I need to take the print. So this is my particular process. So this individual process which consists of definitely two categories of resources are there, physical resources and logical resources. So here I need one particular system. Within that particular system, for example, if you take any processing tool like MS Word, with the help of that particular tool, I need to prepare my resume. Is it right? Then next process, the next sequential process, that is I need to take that particular Word document with the help of the printer. So now the printer is available physically, but that particular printer is allocated to my particular process, that is a old process. So who will allocate? Only the operating system will allocate. So that is specifies here resource allocation. Right? Then whatever the services provided by the operating system, we can mention here. Then the system call. So we will discuss in the next video what is meant by system call, what are the various categories of system calls. Then user interfaces. See, user interfaces, we have different user interfaces like command line, batch as well as the graphical user interface. So these are all the user and other system programs. So this is the operating system services, how the operating system provides some services to the users. That is a pictorial representation. We can call it as a layered architecture, right? So coming to the first one, how the operating system will specify in the form of a user operating system interface, that is a graphical user interface. So the best example for graphical user interface, nowadays you are using the MS Windows, Microsoft Windows, right? We know that MS Windows 95, 98, 2000, NT, XP, Professional, Windows 2003, 7, 10, something. So first of all, this is a user-friendly desktop metaphor interface. User-friendly desktop metaphor interface. So which consists of basically the basic input-output devices or mouse, keyboard and monitor. Here, the icons may be represented with the help of files, programs and whatever the actions. See, there are each and every input device may work with a different principle, right? Just you can take this particular mouse, right? So these have left click as well as the right click. So various mouse buttons over objects in the interface which causes various actions. See, whenever I need to click like this, so it will show something next screen. Is it right? So each and every mouse button click in that particular interface which causes different actions, right? Then which is invented at Xerox PARC. Right, that is the first user operating system interface. Now, many systems now includes both command line interfaces as well as the graphical user interfaces. Right? So, we know the best example for graphical user interface is Microsoft Windows with command line interface, whether we can call as a command shell. So, in Windows also, we may use some commands. Right? Then Apple Macintosh operating system as Aqua graphical user interface with UNIX kernel and shells are available. Right? So that is different systems which includes both graphical user interface as well as the command line interface, but only some systems which have only individually command line interfaces as well as the graphical user interfaces. Right? So this is the example for Macintosh operating system graphical user interface. So you are very familiar about this one because whatever the folders here, so we need to click on that particular folder. It shows some action. So this is very user friendly. Right? We will describe later what is the structure of this particular Macintosh operating system. Then coming to the next one, user operating system interface, that is a command line interface. Command line interface is sometimes called as a command interpreter. Right? So, what is the purpose of command line interpreter? Command line interpreter which allows direct command entry. Right? Rather than using the mouse as well as the keyboard, just we need to interact with the system only with the help of the commands. Right, so those commands may be given to the system with the help of the keyboard only, but sometimes implemented in kernel, sometimes may be implemented by the system programs itself. Right, so some of the operating systems which consists of multiple flavors, we can call as a shells. How this particular command line interpreter or command line interface will work? Primarily, it fetches a command from the user and executes it. Right, so we know the basic thing in case of MS-DOS, right? Just make directory, right? So mkdir, create directory, cd ... something, right? So that particular command line interpreter which fetches a command from the user and executes that particular command. So sometimes these commands may be built-in commands and sometimes those are just like a programs. So in this way, the command line interface which provides some services to the users. The best example for this command line interface, that is a Bourne shell command interpreter. Right? See here, each and every action with the help of only commands only. Then coming to the operating system structure. See, as large as whenever the system is large and complex, these are the modern operating systems must be engineered carefully if it is to function properly and to be modified easily. Right? So, what is the general mechanism to divide that particular system, and we need to use that particular different parts. So that is a common approach is to partition the task into the small components. Whatever the task we are having, right? That particular task is divided initially into the small components rather than one monolithic system. See, this is the part 1, this is the part 2, this is the part 3. So this part 1 is executed individually, part 2 is executed individually, part 3 is executed individually. So whatever the modules, each of these modules should be a well-defined portion of the system. For example, let us take, if we want to implement any particular application, we know that the phases, first one is design phase, then implementation phase, then testing phase, then maintenance, something. So each of these modules should be a well-defined portion of the system with carefully defined inputs, outputs, as well as the functions. So we know in case of design part, right? So what is the input and what is the output? Based on that, what are the various functions? Right? So here we need to discuss about that, how these components are interconnected and melted into a single kernel. Right? So that describes the operating system structure. Right? Within that, many commercial operating systems do not have well-defined structures, right? So frequently such systems started as a small, simple and limited systems, and then they increase the original scope. So the best example for that, MS-DOS is an example of such a system. It was originally designed and implemented by a very few people who had no idea that it would become so popular, because with the help of that particular MS-DOS only we have extracted a number of operating systems. So initial days, this particular MS-DOS was written to provide the most functionality in the least space, right? So it will provide more functions, but it is having very less code. So it was not divided into the modules carefully. So only the operating system which doesn't have any modules, that is a MS-DOS. See, among those operating system structures, first one is MS-DOS layer structure. MS-DOS layer structure. We know this particular MS-DOS, that is Microsoft Disk Operating System, written to provide the most functionality in the least space. Right? Another advantage is here, the MS-DOS is not divided into the modules, but MS-DOS has some structures. Its interfaces and levels of functionalities are not separated. See, this is the layered architecture of MS-DOS. At the bottom level layer, we have ROM BIOS device drivers, right? We know ROM BIOS, read-only memory. BIOS means basic input-output system, right? ROM BIOS device drivers. Then the next level, upper level layer is the MS-DOS device drivers, then a resident system program, and a top level, that is the application program. So this is MS-DOS layer structure. Another example of limited structuring, that is the original UNIX operating system. The UNIX operating system is just like MS-DOS, but UNIX initially was limited by hardware functionality. So in case of UNIX, we have two parts. One is a kernel part, another one is a system program. Kernel part, another one is a system program, right? We will discuss later what is meant by kernel, what are the various system programs, right? So here the kernel is again further subdivided into a series of interfaces as well as the device drivers. So, let us take the initial version of UNIX, which is having very limited interfaces and device drivers. Then the later versions, here the later version in the sense just we need to increase the interfaces as well as the device drivers. So that is another example for layered structure, that is a UNIX operating system. See, a layered approach. Another approach is a layered approach. So what happens in case of previous MS-DOS? What is the drawback? That is not divided into the modules. But whenever we have certain applications which definitely requires, we need to categorize or we need to divide that overall application into the modules. So then we need to approach this particular layered approach. A system can be made a modular in many ways, right? So one method is a layered approach. So what happens in case of this particular layered approach? The operating system initially, which is divided into the number of layers, we can call as a layers or levels, right? So each and every layer or level which is built up on top of a lower level layers. So this is a lower 1, lower 0, lower 1, lower 2, lower 3, and so on up to the lower n. So the bottom level layer is the hardware. So just like imagine that is the bottom level layer that is interacted with the hardware components, right? Like ROM, BIOS, device drivers. Then the highest level layer is the user interface. Always the users need to interact with only the highest level layer. So with modularity, these layers are selected such that each and every layer uses various functions and services of only lower level layers. So each and every one is interacted with the lower level layer only. So how it will resemble? See, this is the layered approach. This is the layered approach. We know the layer 0, that is the bottom level layer. This is the hardware. Only here the hardware components needs to interacted. Then layer 1, layer 2, layer 3 and so on up to the layer n, that is the user interface. So layer 0 is the hardware, layer n is the user interface. So this is a layered approach. See, this particular layered approach is implemented basically, which is an abstract object. So an operating system layer is an implementation of an abstract object which is made up of data and the operations that can manipulate those data. Right? See, any operating system layer, for example, if we take, let us take layer M, which consists of data structures and a set of routines which are invoked by higher level layers. Right? So now here, this particular layer M in turn can invoke operations on various lower level layers. So what is the advantage, main advantage of this particular layered approach is simplicity of construction as well as the debugging. Right? So which is very simple to construct any particular application, and once the application is successfully constructed, then we need to dig into that with the help of the debugging. We need to find where the errors are occur. Then the layers are selected so that each one uses whatever the operations and services of only lower level layers. Right? So this particular layered approach simplifies both debugging as well as the system verification, because each and every layer just it provides some services to the lower level layers. Then next category of operating system structure is a microkernel system structure. Microkernel. See, we know the word kernel. Now here, microkernel. What does that mean? So basically, this particular microkernel structure, the main aim of introducing this microkernel structure is, the basic functionality of this particular microkernel structure is to provide a communication facility between the client program and the various services that are running in user space. Right? So this particular microkernel system structure which provides some communication facility between the client program and various services that are also running in the user space. So the method structures the operating system by removing all non-essential components from the kernel and implementing them as a system and a user level program. So, we can call as a microkernel. We can call as a microkernel structure. So, this particular microkernel structure which specifies that, whatever the kernel, that particular kernel is again divided into the various system level programs as well as the user level programs. So here the communication takes place between user modules using the message passing techniques. So what are the advantages or benefits of microkernel system structure? First one is which is easier to extend a microkernel. So whatever the levels, right, up to that particular level, we need to extend a microkernel. Then easier to port the operating system to new architectures. Right? So we know there are different architectures like a chip level architectures, 8085, microprocessor 8085, 8086. Right? So which is easier to port the operating system to new architectures. So whatever the operating system I am having at present, but whatever the motherboards we are using, that particular motherboards are advanced, then my particular operating system is easily communicated with that particular board. So that is we can call as a port the operating system to new architectures. And more important one is these particular microkernel system structures are more reliable and more secure. Why we can call as a more reliable? Because here the kernel mode which executes only a few lines of code. Then whatever the determinants of this particular microkernel system structure, that is the performance overhead of user space to kernel space communication. So this is the traditional UNIX system structure. So we know basically here that is the kernel as well as the users, right? So at the bottom level layer, we have terminal controllers and terminals, device controllers like disks and tapes, memory controllers, physical memory. See, this is the kernel interface to the hardware. This is a system call interface to the kernel, right? So whatever the services provided by this particular Unix system structure, those are executing in the kernel only. So these are those services like signals terminal handling, character input output system, file system, right? CPU scheduling, page replacement, demand paging, virtual memory. So we will discuss later. These are the important concepts in operating system, right? Then always the users interacts with the shells and commands which compilers and interpreters or system libraries. So this is a traditional Unix system structure. So based on this, there are number of versions we need to evolve, we need to execute, right? We know Unix is an operating system which is limited by the hardware functionality. The original Unix operating system had a limited structuring because the Unix operating system, which consists of two parts, one is system program, second one is the kernel. You know, right? According to this particular diagram, one is system program, another one is kernel. So which consists of everything below the system call interface and above the physical hardware. See, below the system call interface, that is from here, and above the physical hardware. Then again, the Unix operating system, which provides the file system, CPU scheduling, memory management, and other operating system functions, a large number of functions for only one particular level. So that represents the Unix system architecture. Then coming to the modules, you know, most of the modern operating systems implement kernel in the form of modules. Only one particular operating system which doesn't have any modules, those are MS-DOS, right? So what is the advantage of doing this particular implementation in the form of modules? First one is which uses object-oriented approach. You know what is the advantage of object-oriented approach? Then each core component is separate. Then each and every component which talks to the others over a known interfaces. Then each one is loadable as needed within that particular kernel. So these modules, which are very similar to layers but with more flexible. So what happens in case of modules, like as we say that in the previous example, right? My total application program is divided into the various modules like design, implementation, testing, maintenance, something. So here the kernel has a set of core components and links in additional services either during the boot time or during the runtime. Right? So, such a strategy which uses dynamically loadable modules and in common in modern implementations of Unix. What are the modern implementations of Unix like Solaris operating system, Linux operating system and Macintosh operating system? Let us take one example like Solaris modular approach. You know, here the core Solaris kernel, which organized this particular core kernel with 7 types of loadable kernel modules. So these are the loadable kernel modules 4, 5, 6, 7. Right? So this is the Solaris modular approach. Right? So what happens in case of this one? See, we know Solaris operating system structure is organized around a core kernel with 7 types of loadable kernel modules. Those are scheduling classes, file systems, loadable system calls, executable formats, stream modules, miscellaneous modules, devices, as well as the bus drivers. Right? So we have a different functionality of each and every kernel module. Right? So what is meant by scheduling? What are the file systems? How file systems are executed? So what is meant by system call? How those system calls are executed? What are the executable formats? What are the various device drivers and bus drivers? Right? So these are all executed in particular a core kernel, that is a Solaris modular approach. Then Macintosh operating system structure. Macintosh operating system structure. So we know here the kernel environment which is divided into the Mac as well as the BSD, Bourne shell. Then the upper level layer, that is the application environments and common services. See, this particular Mac OS structure, you know that Apple Mac OS operating system which uses a hybrid structure. Hybrid structure, that is a layered system in which one layer consists of the Mac microkernel. See, this is the Mac microkernel which is already executing in that particular shell. So the top layers which includes application environments and set of services which provides a graphical interface to applications. So all of us know that how that particular Macintosh operating system will work on that particular Apple desktops, right? So below these layers is the kernel environment which consists primarily of the Mac microkernel and the BSD kernel. So what is the purpose of this particular Mac as well as the BSD in Macintosh operating system? Right? See, Mac provides memory management. Mac provides memory management. You know, memory management, right? So what type of memories you are using, right? How much memory space is available, how much is allocated, right? So that is particularly which is helpful for remote procedure calls. We can call as RPCs, remote procedure calls, and IPCs, inter-process communication facilities, which includes both message passing and thread scheduling, right? So that is the basic functionality of the Mac, which provides memory management. Then the BSD component, which provides a BSD command line interface, which supports for networking and file systems. Definitely, we need to interact with some particular file systems as well as some routers and all. So, it is simply an implementation of POSIX APIs, including the pthreads. So, in addition to these above two, which is Mac as well as the BSD, the kernel environment. See, this is the kernel environment. This particular kernel environment, which is also provides an input-output kit for development of device drivers and dynamically loadable modules. So that particular dynamically loadable modules, which is generally we can call as a kernel extensions. Right? So this describes that Macintosh operating system structure, right? So this is regarding operating system structure. So in this class, we discussed about operating system structures. In that, what are the various services or functions provided by the operating system, and what are the various categories of operating systems, starting from MS-DOS, then layered approach, Unix traditional systems, modules, finally Macintosh operating system. Right? So I hope you like this video. Thank you. We'll meet in the next video. Thank you, one and all.
Like, share and subscribe. Hit the bell icon for more updates.